Okay, so I have a new installation of Windows because I'm getting a new machine up and running. It's going to be my little AI development workstation in the corner of my living room. Finally, getting off the potato laptop. The potato laptop is still going to be useful for other videos in the future, but it's definitely something that has not scaled well for me. You could definitely still do AI stuff on it. It's just that it's just running into a lot of limitations. But anyway, this mini PC, I'll have a video up shortly on unboxing it and setting it up. It's basically a Ryzen HX9 AI 370. I don't know what the full name is, but it's some high end mobile chip inside a Minis Forum case. It's really compact, but it has like OcuLink, and that's like the most important thing I want to highlight here. And the video will show me setting that up. So OcuLink is the interface that's allowing us to connect external GPU at a lower latency or at least faster bandwidth than regular Thunderbolt 3, which I was doing before. Now, what that enables me to do is I get to use bigger graphics cards because I have an OcuLink dock. And the specific graphics card that I want to use, and this is sort of like a brag, but I don't mean to brag, is that I have a 5090. Okay, so I have a 5090 hooked up to this, and I want to use it for a lot of the AI work going forward, and of course some gaming. But it's been in repair for a long time. It was like I realized it was broken like 3 weeks into getting it, and then I had sent it out for repair, and it was out like for a month, and then it took me about another, like I realized that I couldn't really fit it in reliably into my case, which probably caused like the damage to begin with. It was so big and heavy, my PCIe slots couldn't even support it, so it would get like disconnected, and I guess something electrical happened. But whatever. So in order to like counteract that, I decided to just turn it into like an external GPU, and that's the reason why I got this OcuLink Mini PC. And so this has a fresh install of Windows, and I just want to go through like step for step on how I would set up a development environment, specifically one that has Windows subsystem for Linux and CUDA, right? So I've done videos like this before, but it's all been like fragmented. I just hope that this one is going to be like at least one that anyone else can reference, since it's going to be all in one. So the first thing I'm going to assume is that one should have Windows updated already, like to as much as possible, right? And at least to the point where your graphics card can be recognized by Windows. In this case, I haven't even installed the NVIDIA drivers yet, but Windows Update happened to have found the driver and installed onto it, right? But it's most likely not what I want, so I'll probably install it, a new version of the driver anyway. But before I do that, the first thing I would like to do is install WSL. And so WSL, sorry, I took a pause to install all the necessary browser, Firefox and Chrome and things like that. You kind of need it, right, for various things that we'll be doing. But anyway, so WSL is really easy to install, especially once you have like a updated version of Windows. So it's really just one command. Okay, so I recommend reading this documentation if you want to understand more. And this is like annoying. I didn't even search for any of this stuff. And why is it's trending? Okay, but yeah. So this is good documentation. Just to read it if you really want to know what's going on underneath the hood. But really, it's just this command here, and it's going to install Ubuntu by default. I personally think Ubuntu is okay, especially for compatibility, so it's fine. Yeah, it's okay. So no one's gonna judge. So usually I'll just start up terminal, and I think let's see. Yeah, you'll probably want to run as administrator, so you'll basically want to just go to this drop down, right click, run as administrator, and then it'll come up with this this other terminal box here, and you'll just do whistle install and then just let it do its thing. Right, so it's going to download whistle and it's going to install whistle, and you'll probably need to reboot once, and I highly recommend it, but pay attention to the screen because it's going to ask for a username and a password that you want to be using. And why? Because it's actually, Whistle's like, think of it as like a virtual machine inside your Windows installation, and I'll walk you through that afterwards. But really, here in this case, we do have to reboot. Okay, so I am going to reboot, and then we're going to finish the installation process. And at this point, when you reboot and start up, you could be brought up with the dialog box to finish the installation, or you had to do whistle -- install again to resume the installation. So let's see what we'll get. Hopefully I catch everything on camera. Okay, so I've rebooted, and at this point I didn't get any windows popping up, so I'll just start terminal up again, and just in case, I'll run this as administrator, and I'll type whistle -- install again, and it's probably going to try to continue on. So it does, right? So now it's downloading Ubuntu, so we'll wait for that to finish. It should be quite fast. So it should be like a more stripped down version of Ubuntu in this case. So now everything is installed, and it's launching the instance. But at this point, so you'll have this dialog pop up, and it's just telling you like some cool things about Whistle, and here's like settings on what you can do to make Whistle better. I don't think this is very important right now, so let's come back to it later. But what's important here is our Unix user account, so I'll just keep that as whatever's default. And then what we want to do here is we want to specify our Unix user account password, so I'll do just that. Okay, and now we can use sudo. So this will allow us to use sudo, and at this point, okay, like I don't use Whistle like this. This is not how I use Whistle. How I really use Whistle is, again, same terminal, but you'll have an option here that has Ubuntu now. So if you click on this on a Windows terminal, you'll be brought up to the terminal that corresponds to your Whistle instance. Okay, so this program is called Windows Terminal. So I'll just pin here. Now you can make this the default, right? You can make this the default with settings, okay? And then startup, you could say default profile could be Ubuntu, which I like, okay? So the default terminal application, I also want this Windows Terminal to be the default terminal. And then let's see, appearance, okay? Appearance. Let's go to appearance. Ubuntu. Yeah, I don't really like that purple, so I'm going to change it to something else. I'll change it to 1/2 dark. I do like 1/2 dark, but dark plus is also really good. I'll do dark plus. So I'll change it to dark plus, and then I'm okay with the fonts right now. But maybe I'll change the font size so that everyone can see my commands. Okay, so should be good now. So now we can use Ubuntu here. So if I ls, this is my home directory. If I ls root, I have everything in here, so that's good. And if I pwd home urban, so just like regular Linux, but now you're seamlessly going back and forth, right? And so how you access your Linux file system is through here. So if you were to open up the file explorer, you'll have this Linux drive here that you can just drop files into. So for example, if I want to drop something into my home directory, I can do just that. So I can create a new text file, for example, hi, and then just edit it with, okay, got it, whatever. Oh, okay, fresh install Windows. Hi. If I were to ls again, I'll have that text file, and I can cat that out, and it'll be hi right here. All right, so that's how we play around with the file system. Basically, the full path here is going to be //whistle.localhost/Ubuntu, and then basically this will be your root directory here, and you can access everything. So it's not like a Windows drive where you had to do like C://. It's really different now. This is going to be the root to your Whistle instance. Mine is Ubuntu because I installed Ubuntu, but basically it maps back to everything in here. So you'll mostly probably want to stay within your home directory. So if I were to be in this root here, I could just double click on home and get into my home directory here. And just so you know, in Windows, dot files, so .bashrc, .profile, these are not considered hidden files in Windows, but it is kind of hidden in Linux. So since you're on Windows, you'll see them visible here, which could be a good thing if you're wanting to do something like, for example, like create SSH keys from here for whatever reason, even though you can probably just create it from the command line or like import them in this case. So, okay, so development environment. So let's do this. Let's get VS Code and see how we can actually develop inside our Whistle instance, because it's actually different, right? Like, what if you wanted to create a new project? Excuse me, there's something going on in the background that's really okay. So now we want to develop in Whistle, and that's actually different than just like opening up like for example creating a project in here and then opening up that folder through this path, right? That's really not the right way to go. What you really want to do is you want to remotely develop. Even though it's on the same computer, your Whistle instance is considered to be like a different computer in this case. So you're kind of like SSHing in to develop. If you have VS Code or anything that is VS Code like, you definitely can just automatically do a remote connection to your Whistle instance, and then everything will work seamlessly like from there, and you can develop as if you were on a real Linux machine. So let's get VS Code for now. No, not now. Okay, Visual Studio Code. Let's download Visual Studio Code, and I'll see what I'll show you what I mean in terms of connecting to your Whistle instance to be able to develop. So I'll install VS Code quickly. Let's see, create desktop icon. No. Okay, register, add to path, whatever. Okay. Okay, so launch Visual Studio Code. Okay, cool. So I'm going to pin this because I develop a lot. And you know what? I'm also going to unpin some stuff that I won't ever use in this case. Okay, so this is Visual Studio Code up now. Now, at this point, you're developing on your Windows side of things, and you want to develop on your Whistle, WSL, Windows System Subsystem for Linux side of things. So if you see this icon at the corner left here, open a remote window. If you click on that, you will have a bunch of options in how you would like to develop. In this case, you're most interested in using Whistle, WSL. So we can click on WSL, and it's going to install an extension that allows for remote development in Visual Studio Code. It's going to pop up a new window. This window here, if you look down here, is connected to your WSL or Whistle Ubuntu instance. I'll just call it Whistle from here on. I don't want to correct myself all the time. Basically, at this point, it's like your secure shell connection with your other favorite IDE type of development pattern. So if I opened a folder here, notice how now everything is Linux-like. At this point, I am in my Linux virtual machine. So if I bring up a terminal, for example, with Control tilde, okay, here is the same terminal that we would see here. Okay, so I can touch hello.txt, ls, hello.txt, ls, hello.txt. Everything is now linked together. As long as I develop in Whistle, I should be able to experience the same things I would experience on Linux. What does that mean? It means that I can do CUDA development, or at least AI development, or whatever development you want to do. I could do GCC too. So in this case, if I wanted to compile a C program, I wouldn't need to go through shenanigans and setting up MinGW or anything like that. I can just GCC normally inside WSL. Now in this case, I don't have GCC installed because WSL it has an Ubuntu installation that is quite minimal. So I would need to install a few things to get myself up and running first. So let's install some basic development tools in this case. Do I have Git? Okay, so we do have Git, but do we have Git LFS? So we don't have Git LFS. We will need that because if you're downloading a bunch of models from Hugging Face, you will need Git LFS. So the go-to like basic set of commands that I usually want to install in this case is a build essential. So build essential, Git LFS, and then Py environment, so that I can switch between Python versions quickly. Okay. Oh, and tmux. So I don't know if I have tmux in here. Oh, there is tmux in here. That's cool. Okay. First things first, sudo apt update, because you want to be able to get updated package lists from the connected repos. Oops. And that'll allow you to pull down the latest versions in these repos for Ubuntu 24 on these essential dependencies that you need. Okay. I don't know if it's going to take that long. Okay, it's probably good now. Okay, cool. So I've updated my package list. So I'll just install the things that I said I was going to install before. So that's sudo apt install build essential, which is going to have all the C dependencies and things like that. I'll also install Git LFS because I need that. And that should be good for now. So we'll get to more things later as we move along. But for now, we need these basic development tools. Now, in the meantime, let's actually go and see what it would take to install Py environment so that we can switch our Python versions in this case. So how do we do that? So Linux, Unix here. So we can just curl for PyInv, and then we just need to add stuff to our bash rc file. I think it's just a copy and paste of this. It'll prompt us for it too after we're done installing it. So here I'm just going to copy that so everything's done, and I'm just gonna, oh, before we do that, we had to install Git LFS, right? So you initialize it with Git LFS install, and now you have Git LFS initialized. So if you were to clone Hugging Face model repo, for example, now you would be able to actually get all the files in one go. Okay, so now here's Py environment. So let's install that. Just run the script, and it's going to ask, okay, well, we want to be able to switch and add Python to your path correctly going forward. So just copy this right here, okay. And then what you can do is you can use nano, vim, or whatever. So in this case, I use vim, okay? So vim tilde.bashrc. You want to add whatever you just saw into your bashrc file in this case, okay? So now if you sourced bashrc to reload your environment, you should have pyenv ready. Oop, pyenv. Wait, did I not copy and paste that correctly? I probably didn't. Why? Whoa, it's reading it as one single string. Okay, so that was probably not a good thing. Okay. How do I get this cleanly? I know. Just copy here. Okay, so we just want this one, I think. Yeah, there we go. Oops, we don't need to do that. That was just echoes, so sorry, don't know what I'm doing. Okay, it'll add for us if we just run these commands like that. And then I think if we were to go in here, yep, they got attached. Okay, So then we could just source bash rc again, basically echoing it into our bash rc by appending it. Pyenv. Okay, now we're good. So right now we have Python 3.12. That's usually the right version, but you can install different versions of Python by doing pyenv install and then your version, for example 3.11. I'm not going to do that, it just takes too long. So, and then you can set it as a global version by pyenv global 3.11, for example. I like 3.12. It seems very standard for everything. Okay, so Python, we're good. Okay, at this point. And from here, you can install like the Python extension, right? So in your VS Code, you can install Python extension. So now you can have Python related things in here. I think it'll install like Jupyter and all other stuff too. We can worry about that later. The next most important thing if we want to do some AI development is, of course, getting the CUDA toolkit. So the CUDA toolkit. Okay, so before we do that, but I just want to show you, turn off optional cookies. Okay, so CUDA toolkit, you just get developer.nvidia.com CUDA toolkit, download now. Basically, you'll be presented with two options to choose, the Linux or the Windows version. Okay, in this case, you do want Linux. Okay, you want x86-64, and you want the WSL Ubuntu. And there's only one version of WSL, it's 2.0, and you want to just get it through network, so you just want to re-download stuff. And you're just going to run these commands. But before we do that, I don't know if this makes a difference, but let's just get the latest drivers for Windows on our graphics cards. Okay, so let's just get the latest drivers for our 5090, for example. And I'm just do the professional workstation users one because I want stability. So I'll download the drivers there. Is there a way to do that? Or maybe it's get automatic. No, I don't want that. Maybe it's here. Yeah, we probably had to do it from here. So I don't know. We have a 5090. Oh, studio driver. Here we go. Okay, cool. 5090. We have a 5090 desktop. So 5090 desktop. Oh, this takes a long time. Okay, 5090, and then we have Windows 11. Okay, so yeah, let's get the studio driver because that's for like professionals and workstations, and it's more stable than the game ready driver. So I'll just download that, and then I'll just install the driver. So just download. 581 is the latest driver apparently, so let's get that and then install it, and then we might have to reboot the system one more time just in case, and then we'll install the NVIDIA toolkit, and then we'll reboot the system again just in case. So we'll install this driver first. Okay, just extract it and I'll just get out here. And remember, so since we've set our terminal up correctly already, we go right into our Ubuntu shell. But if you're unfamiliar, just drop down to here and create a new shell here. Okay, so that's how you get into your Ubuntu environment. And then when you're connecting in Visual Studio, if you're not already in the WSL Ubuntu, you can always connect to WSL option here from down here. So, but you already know if you see your terminal correctly and you see this down here, you're fine. Okay, so just remember, the one thing you need to remember is that you need to access your file system. You go here. Okay, you go down here in the Windows file thing, or you can hit it directly with this URL. So whistle.localhost Ubuntu. So let's continue with the graphics driver. I think the NVIDIA app is fine, I guess. Okay, so I like to do a custom install because I want to do a clean installation. So I'm going to do a clean installation, and I'm just going to let this thing go. Now, I don't know if recording is making a difference in terms of will it affect things. I think it's probably using my integrated GPU anyway. So let's bring up Task Manager and see what's going on. Okay. So basically, the recording cut off because OBS was actually using the NVIDIA card to capture the video. So I've changed the settings to now use my integrated AMD card right here. So now you'll see a lot of activity going on with this little integrated GPU. This one, I don't know why there's activity, but whatever. At this point, drivers are done installing, so I'm going to close. And the next step is to reboot the computer and then just hope that everything is working correctly. And then once we're done with that, we will install the CUDA Toolkit. And there's a lot of caveats to that, and then we'll verify whether or not it actually works. So see you soon. I've rebooted. Everything seems okay now. I can still see my GPU. So you see there's 59 still connected. Everything's still good. Drivers install looks okay. You can even verify that with the device manager, for example. And then just go to display adapters and you'll see 1590 here. And then driver date is 10/9/25, which is quite recent, I guess. Yeah, and other things here that probably we don't even care about, but it's there. Anyway, time to install CUDA Toolkit. So let's go and install CUDA Toolkit for our WSL system. So going back to our CUDA Toolkit download, we'll just choose Linux because WSL is still Linux, x86-64, WSL Ubuntu 2.0, network. Now, from here, we want to fire up our terminal again, and by default, we've already set it to Ubuntu, but if not, you can just set it in the settings here by going to settings and this drop down here, just choose that, or you can just start up manually by just clicking on Ubuntu here, but I'm okay, I have it already up here. So I'm going to first copy and paste each line to just do one thing at a time, and one of these packages is actually pretty big. Not sure which one it is, but I think it's probably the CUDA Toolkit itself. But you want to add basically the NVIDIA package repository into your package list so that going forward you can actually update CUDA or install things as you need from the repo. So I've already added the NVIDIA package repo, so I just need to now apt update so that it's recognized and we get the package list from NVIDIA. And if we were to run this, you'll start to see that we are now updating from NVIDIA also in addition to Ubuntu Noble. Okay. Okay, so everything is good. Okay, so now we just install CUDA Toolkit 13.0, and that's just an easy command. Just apt install, and then it'll just download a whole bunch of stuff. There's a lot. It's a big file, so we'll come back to it when it's done. The CUDA Toolkit is now installed. And now what we want to do is we want to follow the post-installation instructions detailed here. That's what the documentation says, right? So what we're looking for is updating our environment variables to include the CUDA compiler and all that other stuff. So I think we want to navigate down to post-installation actions, and there's like mandatory actions here. We need to set up our environment so that it recognizes all the CUDA binaries. So we need to update our paths, right? So copying this, we'll just edit our bash RC file. At the very end, just append, okay, the line that they tell you to append. So you're updating your path variable here. So now this directory is included with the rest of your path. And then you also want LD library path, which is where it's going to find all the static libraries and dynamic libraries and all that other stuff. So there we go. Okay, so it also includes your current one too. So source.bashrc, that refreshes the environment. And how you can test if that worked is if you typed nvcc to try and compile some CUDA thing, and it should say NVCC fail because you have nothing in there. At this point, we're good. Now, there is also, I believe, Windows whistle caveat. Yeah, okay. I think... Actually, I think we did everything. I think at this point, we could do NVIDIA SMI. Yeah, if we did NVIDIA SMI, if you see the video card that you have inside your whistle system, you are now good to go. You now have CUDA installed in whistle, and now your whistle environment can tap into your GPU and do cool things with it. Okay. Just a reminder, how you start up your environment is, with VS Code at least, is to just go down here and connect to Whistle. And same thing, I'm already in Whistle, so I could do NVIDIA SMI, and I find that I have my graphics card good to go, ready. Next thing is SSH keys. I have copied my SSH keys into the .ssh folder within my Whistle home directory, but it is not ready yet. What we need to do is we need to chmod with the right access permissions so that we can actually use them for anything that requires our SSH key. Chmod 600 tilde SSH ID RSA, and then idrsa.pub. Now I have my SSH keys good to go. I can clone my own Git repos. I can even use Hugging Face if it's connected through my SSH keys. I could do everything now. At this point, actually, I'm good to go. I'm ready to develop. The rest is just whatever you feel like doing. You just install those additional dependencies. But the development flow is really like this. It's more like you need to understand that Whistle is it's different from your Windows in general. It's a different environment. If you ever want to use Windows Terminal to access your Ubuntu installation, you just drop down and just select that as your shell, or you set it as default so that whenever you start Windows Terminal, you're there. And every time you want to access PowerShell for whatever reason, you can just do the same thing here. Okay? You need to make sure that you set your settings, at least the appearance settings, in a way where you can always distinguish between like what's PowerShell and what's Ubuntu. That's like super helpful. And the next thing is that understand that it is a different file system. In this case, it's seen as like a networked drive. Okay, so it's going to be whistle.localhost /ubuntu/ wherever you want to go. This is the root directory right here. In most cases, you can just tap into it here and you'll be fine. Okay. Rarely you'll probably ever need to do that because you'll probably be doing everything through command line, through SCP, through whatever. And then for development environment, VS Code, for example, you can connect to Whistle. You can also do this in PyCharm too with JetBrains. We'll do that maybe in another video, but really you can connect to your Whistle environment too with PyCharm, for example. Yeah, that's about it. I mean, the trick is just to get CUDA installed correctly and everything all linked together, but I think we're good. We can try something next time. Thank you.